Hi, welcome to New Ways to Optimize Civil Designs using Autodesk InfraWorks 360 2016. My name is Richard Johnson. I'm a project manager with Cansel for Geospatial and Civil. We're doing this in conjunction with Autodesk. I've been working for Cansel for the last 6 years as a consultant in the professional services division. Prior to that, worked at the City of Vancouver in the engineering department. We're going to focus on several key areas today, one of them being data sources, using InfraWorks Model Builder, and looking at recap data sources. We'll also look at Civil 3D, interoperability, terrain analysis, shadow analysis, and feature themes as they relate to picking a site to develop. We'll have a brief demonstration, a summary of what we've done, and a period for questions. So some of our goals for today to set expectations are to introduce some of the new features for InfraWorks 2016, provide an introduction to Model Builder, look at Recap 360 data sources, look at InfraWorks 360 and Roadway Design for InfraWorks 360, review some of the analysis capabilities, and understand the business benefit for what we're doing. So a few of the new features for InfraWorks 360 are there is a new name for InfraWorks LT, which is included with the infrastructure design suites. InfraWorks 360, bridge design, drainage design, and roadway design are separate products. There's an enhanced point cloud processing engine in 2016, as well as enhanced Civil 3D data exchange. There are new roadway design tools, new drainage design tools, enhanced cloud collaboration, new grading tools preview technology, traffic simulation preview technology, where you can simulate traffic on design roads, and network drive model support. There's also a brand new screencast recorder inside of InfraWorks 360 to help you capture and record models for use in presentations. All of these tools and more are available in the new InfraWorks 360 product. There's no way that I'll be able to go through all of the features of InfraWorks 360, but I hope to focus on some of the key features to bring us through. Creating your 3D model using Model Builder has a new feature that allows you to bring in a shapefile to define your area of interest. The data sets that are included when you create a model for elevation, imagery, roadways, and buildings are defined on the beginning of the Model Builder page. Elevation was created from shuttle radar topography that was flown in the late 90s. This information does have inherent inaccuracies, and I get this question often. So it's great for preliminary planning, but know that you will have to get more accurate information for engineering design. The imagery comes from BIM maps. The roads and highways come from OpenStreetMaps, and the buildings also come from OpenStreet. So these combined together provide you with a very easy interface using BIM maps to select your areas of interest and produce your initial 3D model. We'll review some of these 3D models in InfraWorks during the demonstration. Another data source is using Recap 360 for photos and laser scans. So Recap 360 will process this information for you to produce point clouds that can be used inside of InfraWorks 360 and inside other products to refine point clouds and create 3D meshes. It's the move from using point clouds to using 3D meshes that is an exciting use of this information inside of InfraWorks 360. Data can be captured from quadcopters, such as this one, to produce three-dimensional models, such as this. This is what Recap 360 Online will do for you. At the next level, using a fixed-wing drone can provide you with digital elevation models like this if you're looking to cover greater areas. After upload to Recap 360, the photos are stitched together and processed to create 3D point clouds. You can see where a drone was used in this case to capture pictures at various angles, maintaining a relatively constant distance and height to produce this 3D model. After the point cloud is exported, Memento, which is an Autodesk Labs product, can be used to further refine your 3D mesh. This information can then be output for use inside of InfraWorks to create more detailed landscapes that are no longer just a point cloud and can provide powerful perspectives for clients viewing this information. Civil 3D interoperability is another area where we can now open InfraWorks models inside of Civil 3D to further our planning and design process. So models can be refined in Civil 3D and then opened back up in InfraWorks downstream. So here's the same alignment in InfraWorks. Through visual analysis, you're able to create themes for terrain, such as elevation. You're also available to create themes on features and their properties, in this case, building height. These types of interactions are readily available through the analysis menu. Here's a new feature where we can now theme point cloud information inside of InfraWorks to provide perspective on intensity and elevation that was done using the point cloud creation initially. So we are now able to read that point cloud information inside of InfraWorks. Visual analysis can be done through line of sight, where all of the features that can be seen from a particular location, or all of the features that can see that location, are available. Time of day and shadow analysis can be easily performed within InfraWorks so that you can view information and how the shadows will fall on particular areas at different times of the day. Suitability maps are another new feature that are available that can give you insight into where the best areas for development are located. So building heights, proximity to water, proximity to existing infrastructure can all be factors that you can add in to define where a suitable location is for your next development. So let's move on to demonstrating InfraWorks 360. I've created a couple of different examples using the InfraWorks Model Builder. The Model Builder itself is easily accessed in the home page of InfraWorks in the new interface. By searching using Bing Maps, you can zero in on the area, in this case Calgary, that you want to build a model of. As you zoom in farther, it defines your area of interest. Alternatively, you could have used a shapefile to do that. Once you hit submit, it does take some time to process and you'll receive an email when it's ready. Let's look at the model that I created for the City of Vancouver. As you can see, it has a robust set of information that was created for me using this tool. If I zoom in on an area, all of the 3D buildings existed in the model and were downloaded after the model was built. So really a very rich set of data can be created quickly using the Model Builder tool with no effort, very little effort at all on your part. I was able to extend the model by downloading information on the Open Data page from the City of Vancouver website. So information such as utilities can be integrated into your model from various data sources. In this case, a shapefile was used to create the sewer main and manhole infrastructure. I exaggerated this for effect so that it could be easily seen. However, it's very evident that we can create these models quickly and easily using a variety of source data sets. Zooming around the model is very quick and efficient. I know that it might be choppy on the web demo, but know that for myself, it's very responsive. If we zoom into a particular area and we want to understand what is visible, what we can see, and what can be seen, we can use the Select Visible command. This is now selecting all of the features that are visible from that location and all of the features that can see that location from the current perspective. So a very powerful way to evaluate visibility very quickly with just the click of a button inside. As we mentioned, powerful themes can be created using terrain analysis, such as elevation, based on the digital elevation information that's been incorporated into your model. Adding a new theme is very simple, and you have a number of options available. You can very easily increase the number of rules that you're applying, name it, and adjust the colors as required. Very fast and efficient way to theme based on terrain. Features themselves, such as buildings, or any of the data sources, can also be themed based on their properties, such as attributes, or in this case, building height. So again, fantastic perspective and easy to create tools. Here we're going to use sun shadow analysis by changing the time of day to change the shadows cast, so that you can view the shadows cast based on a particular date. As well, you can increase wind speed, direction, and cloud cover to simulate what's happening in the sky. Just going to clear my selections and use these bookmarks that are so powerful inside of InfraWorks to be able to find locations that you've used in the past for the information that you're describing. So here we're reviewing another type of data source that has been imported from Recap. The first is the example that we saw on the slideshow on the left. And you can see how detailed that information is and how responsive it is inside of InfraWorks. We are sitting this building on the preview building grade object. That's new in 2016. And you can see that this now has slope to ground characteristics to create a building pad for this 3D model. If you look at the properties, there's rules now available for manual grading and rule-based grading based on styles. Here are the styles that are currently available. We've used a 3-to-1 slope on cut grass for this particular style for this building grade. So something else we've been experimenting with quite a bit at Cansel is the use of this Recap 360 imagery over larger areas to create landscapes and buildings inside of InfraWorks. And you can see that we're having quite a bit of success being able to create realistic surroundings. This one of a rugby club in Burnaby that we have transported to Stanley Park in Vancouver. I flew this imagery just a couple of weeks ago, and it only took about 15 to 30 minutes. So very easy and powerful. This is the same information in Recap 360 after it's been processed. So you can see that here's our point cloud information and the locations of the photos and where they were taken from to create this model. So it's never been so easy to create three-dimensional models from relatively inexpensive photography. This was done with the GoPro Hero Silver 3 attached to a quadcopter. So amazing that now we can work with 3D mesh information processed through Project Memento and bring that into InfraWorks as a 3D mesh and not just a point cloud. And we can use buildings from other areas and bring them together to create options for future designs. And again, the performance based on your hardware is quite good. Now that we have a building grade, we might want to know what the cut and fill or terrain characteristics are for our new building grade and terrain. You can see that very quickly by outlining the perimeter, we can define the area and the total cut and fill and net from our preliminary design. So our next example will be Civil 3D interoperability. We all know how easy it is to design information using powerful styles in InfraWorks. Using the Roadway Design module, we can design roads that are compatible with Civil 3D. So here's an example of an arterial road that we are building in one of the last few remaining areas inside of Vancouver that would be available for development. So here's our design road. And for effect, we can not only look at two-dimensional design options, we can also look at it in profile to create three-dimensional design options. And here we're going to put ourselves into a fill and a cut situation for this road. Now that we've created that design inside of InfraWorks as a preliminary design, let's go ahead and open Civil 3D. Here's a template corresponding to the approximate area of our InfraWorks model and our new road design. You can see that there's a new InfraWorks 360 button available under the Insert tab in Civil 3D. Here we can directly open an InfraWorks model that we've been working on and access the objects inside. You can see that even though the coordinate system of the original model is lat long, we want to, of course, work inside of UTM. So we can set that up. We don't want the entire extent of this model. We just want to define a subset or an area. So here we can use the Bing map connection so that we can better define where the area that we want to extract from our InfraWorks model is. We can further choose or refine the information that we want to bring in using the Refine Selection Set option. So we do want our surfaces, but our planning roads, as opposed to our design roads, really aren't of use to us inside of Civil 3D at this moment. There is the option to bring those roads in as well as the utilities for pipes and structure, and of course, the design roads. So let's remove the planning roads and the pipes and structures and only bring in our design road and the surfaces into Civil 3D. Let's go ahead and open the model. We can turn off our Bing map information now because we brought the information into Civil 3D. And you can see that there is an alignment that we created inside of InfraWorks now in Civil 3D, and it's available through the prospector tree. We're going to now create some other elements that are required to do more detailed design in Civil 3D, such as a profile. So here's our profile and our existing ground as exaggerated. You can clearly see where we put ourselves in a cut and fill position in our design road. We'll just use the primary road assembly so that we have a complete assembly to create our corridor with. Now that we have those, let's go ahead and create our corridor. I'll just have to pick them directly from the drawing. There's our corridor style. We'll just choose a basic style. There's our alignment style. We'll pick our assembly directly from the drawing. And it looks like we'll have to pick our surface directly from the drawing too. So let's pick our existing ground surface. And let's create our corridor. We'll just accept the default baseline and region parameters and rebuild the corridor. So now we have a corridor that we can use to create a corridor surface. So let's use our top links and create a corridor boundary, use the corridor boundary to create a corridor boundary surface as well. And rebuild the corridor. Excellent. So now we can do some of our edits and save this information . view it in Autodesk InfraWorks. So when we open this back up, we can zoom back into our design road. Delete our existing design road and get ready to bring the other information in from Civil 3D. So let's go ahead and delete that road and add our data source from Civil 3D. So here is an Autodesk Civil 3D data source, and here is the file that we saved. So we don't want all this information again. We really just want the design road information and the final corridors because we already have the existing ground surface to work with inside of Civil 3D or inside of InfraWorks. So let's click OK. And let's just configure one of the road object and add a more meaningful style. Hit OK. We'll pick our features and refresh all of the information. So there's our new Civil 3D generated alignment and surfaces. We'll go ahead and go back into Civil 3D and make some design modifications. So in our profile, we clearly have a cut and fill position, so let's just decrease some of the fill that we have to do. Save our file. And go ahead and change some of our alignment information. There we go. We'll rebuild our corridor. Save our file. Go back to InfraWorks. Pick those data sources from our selected file and go ahead and update. So there's our new road alignment with a decreased amount of fill for our design road. So powerful interaction between InfraWorks and Civil 3D. So here's another example of an alignment with a bridge. That was created just by clicking a design road across the water, and because it's water, it knows that it's a bridge. When we bring that information into InfraWorks, we can do it the same way that we just did and select the area where our bridge and design road is. We'll go ahead and get rid of the information that we don't want to bring in and keep, and you can see that there's a bridge now also available to be imported. let's turn off our Bing maps so that we can see the information. Zoom in. And now let's take a look at our imported bridge. And go ahead and look at that in our object viewer. Go ahead and create a profile for that alignment. And you can see our exaggerated bridge alignment. But because those have been imported as solids, we can go ahead and project those solids onto our profile. So very powerful that we can have this level of interoperability between InfraWorks. So in summary, we've created a very realistic 3D model using both Model Builder and external data sources such as Recap 360. We can also use those tools to determine the best location for design elements based on analysis. Those analysis tools are terrain themes and terrain statistics, sun and sky analysis, and feature themes and measuring features. Site and line of sight analysis is accomplished using the Select Visible tool. And hopefully now we've understood the business benefit of all of these features. So here I'd like to open it up to questions. I'll give everybody a little bit of time to use the GoToMeeting chat window to submit your questions. I see quite a few coming in. So let's go ahead and answer the first one. So are utilities part of InfraWorks, or do you need InfraWorks 360? Utilities are, if I understand the question correctly, part of InfraWorks, the core product, so now InfraWorks LT. And you do not need InfraWorks 360 to bring in subsurface utilities and model them such as I did inside of InfraWorks. Another question is, can you export to other 3D formats like FBX? And the answer is absolutely. You can export your model in its entirety or an area of your model, which I recommend, to formats like FBX to be used in other vertical products or other three-dimensional rendering software, such as 3D Studio Max Design. And it works very well. I've done it myself, and the information comes through in a very detailed way. So another question is, do you have experience with RDMS or relational data management systems? And the answer is yes. You can connect to relational data management systems data sets inside of Civil 3D and use them interactively, just like you would use any of the other data sets. And I have tried them for Oracle and SQL Server, and they work very well. They read the information from the data source and bring it in to InfraWorks and render them in the model, and only go back to the source when you reprocess it. So yes, absolutely, this information is available through the data connection source in InfraWorks. Can you use the grading tools in the preview mode? The answer is yes, but know that anytime that things have been released as a preview inside of Autodesk software, that it is subject to change potentially. So you can use it, but know that in future releases, this information might be changed, or the tool might be changed in future releases. Well, okay. Thank you very much. I think that this has been an excellent set of questions that have been put forward, and I hope to see you in future sessions and webinars created by Cansel and Autodesk. So thank you very much.